Welcome back to part 2 of chapter 4, lesson 4, rational numbers. To compare two rational numbers, you can compare the signs as well as the magnitude or the size of the numbers. If the signs are different, the positive rational number is always going to be bigger than the negative rational number. That's pretty simple to think about. So you're comparing positive 1.5 and negative 1.2. The signs are different, therefore you know that the 1.5 is going to be greater than the negative 1.2. The alligator is going to eat the 1.5 every time. If the signs of the two rational numbers are the same, however, then it would be a good idea to graph the numbers on a number line to compare them. If the numbers are written in different forms, it may help you to graph the numbers if they are both written as decimals or if they're both written as fractions. Greater numbers are graphed farther from the right, farther to the right on the number line. So now we have a negative 1.5 and a negative 1.2, similar to the last problem, but now our 1.5 is negative, and when you graph it, you can see that the 1.5 is further to the left because it's negative now. That means the 1.2 is going to be the bigger number, and you can see right here the alligator is eating the negative 1.2. Easy math. Anybody can do this stuff. But what if we get our rational numbers given to us in different forms? For example, right here I've got the decimal form of a negative 51/100ths and the fraction form of 12 over 20, negative 12 over 25. So I know how to do those in my head, but some of y'all that may be a little tough. So let's see how they say we should be working it out on paper. Now the textbook made this magic voodoo math leap here where they magically went from negative 12/25 to negative 48/100. Let's take a look at how they got there. So I'm going to take and pull this up on our whiteboard, and we're going to take and maybe get it to work. Here we go. So I have a negative 12 over 25. And I got to change it to a decimal, and the easiest way to do that is going to be to get it compared to something over 100. And I don't know why my mouse is so bad right now. Something over 100. And I can say 25 times what number is 100? It's going to be 4. If I do it on the bottom, I have to do it on the top. So then 12 times 4, that's going to give me a 48. And of course, we have the negative number carried through. Read the number to me now. 48/100ths or negative 48/100ths equals negative 0 and 48/100ths. And that is where they got this magic number you see right here of negative 48/100ths. They just made that big leap without justifying it, and you know I'm pretty big on having justification for your supporting work. Next thing we're going to do is going to be to graph the two numbers on the number line, and they're going to be really close to each other. So let's take a look and see if we can do this. On our number line we have, oh good, they have it broken down into 0.1, 0.2, so these are actually hundredths of a space. So now we can take and say negative 51/100ths. That's going to be there because this is negative 50, negative 51, negative 52, and so on. This one is going to be negative 40, 0.4, 41, 42, 43, 44, all the way up to 48. And we can take and check our math, and why is it saying we're wrong? We're not wrong. I had just hit the show answer button, and it gave the same answer as I did. So there's the answer they did when I hit show answers, and then my answers, it's the same exact thing. So, ugh. So with that information, we know that negative 51/100ths is going to be further to the left on the number line, meaning that it is going to be less than the negative 48/100ths, also known as the negative 12/25ths. Now, let me remind you on your homework, you can't just throw down a less than symbol there. You're going to have to give me some supporting work like I did right here, showing how you converted to a common base so that you could truly see 100% for sure which one was going to be the bigger number. Now it's going to be your turn. Pause the video and work through this problem. Make sure you are giving me good high quality supporting work just like I showed you before you submit your answer here. Did you get it done? Let's see how I would work this problem. I'm going to take that 5/8 and I'm going to change that into a decimal. And this one isn't going to be as easy as the last one. The last one we just multiplied by 4, but there's no whole number I can multiply by 8 to get to 100. So instead, I'm going to take and divide it out using some long division, which means that 5, the first number goes in the house, the 8 goes outside the house, 8 goes into 5 0 times, annex in the decimal and a 0. 8 goes into 46 times, which is going to be 48, 2 left over. Bring in a 0 and bring it down. 8 goes into 22 times, which is going to be 16 with 4 left over. Annex in another 0, bring that down. 8 goes into 45 times, which is going to be 40 with nothing left over. So this answer is also going to be a negative 3.625, which means this is the first time we've looked at a little problem on the lessons where they are actually going to be equal. So I can go over here, hit equal, check my answer, and the answer checks. That is showing your work, folks. This is what I must see. If I see anything else, you will have done it just for fun. So let's keep going with our lesson on ordering rational numbers. The instructions say to order rational numbers, follow these steps. Step 1, write each value in the same form. Since there may be different denominators in the fractions, it may be easier just to go ahead and convert them to decimals. And this is one place I agree, fractions are not necessarily your friends. 2, use the signs of the number, place value, and other or a number line to compare the numbers. And then finally, step 3, order the values from least to greatest or greatest to least, depending upon what your instructions are asking you to do. So now we're going to take and move through the slides to the set of numbers that they have given us: negative 1/4, negative 3 75/100, negative 17 over 50, and then we have 3 0 and 3/10, which is going to be positive. So moving through the slides, they start out with negative 1/4 is the orange one. I'm sorry, not negative, it's positive 1/4, because 1/4 is 25%, and it's also known as 0.25. Moving on to our next number, the green is negative 375 thousandths, and that would have ended up being about here on your number line. You got negative 25 hundredths, negative 5 tenths, also known as 50 hundredths. You could call this negative 250 thousandths and negative 500 thousandths if you wanted to, and that's a good way to get to where negative 375 thousandths is going to be. The next one, negative 17 over 50. Well, 17 over 50 is the same thing as saying 34 over 100. So now you're looking at 34 hundredths, which is going to put you somewhere around right there, which you can see they just highlighted. And then the final answer, a positive 0.3. That's going to be 3/10. You've got 25 hundredths. You got 5 thousandths. 0.3 is going to be about right there. And we click it and look, I was right where I needed to be. So least to greatest. The least is going to be the value further to the left, and the greatest is going to be the value further to the right. So now we're going to order our numbers. The least number was the green one, which is negative 0.375. So we're going to take and type in a negative 0.375. And then the one after that was going to be the orange one, which was going to be a fractional value of 1 over 4. 1 over 4. Accept that, and then going from greatest to least is going to be the opposite order of what we just did. So I'm going to put the 1 over 4 here, and then we're going to put the negative 0.375 right there. Check our answers. Give it time to check or save itself. It didn't save itself. What happened there? Let's try that again. Negative 0.375. Accept. There, it's in there. And check. And everything checks. Excellent. Now we have another problem that's going to be very similar, only we have got more fractions involved in this one, but there's only 3 numbers, and those numbers are going to be very close to each other when we're going to be graphing them. Once again, I asked, how can you order rational numbers when they're written in the different forms? write them in the same forms. For this one, it's going to be easier to change everything to a decimal because you have 2500ths and you have tenths. You've got different denominators in your fractions. Just change it to a decimal. It'll be much easier that way. Now, I'm not going to show you the grunt work on these because I've shown you a couple times already, but the decimal values of each of these mixed numbers are shown right here on the right. So from there, we're going to take and plot them on a number line, maybe? Maybe not. Let's see. What do we know? Yep, we're going to plot them on the number line. So negative 2.46. That's going to take, and we got negative 2.4. 1, 2, 3, 4, 5, 6. That one's going to land right there. Next one is going to be negative 2.88. So let's change the color of our number here. That's 2.8. This is 2.9. 2.88 is going to land us right there. And finally, a negative 2.1. Get a different color here. That one's going to be easy. It's right on the spot right there. Check our answers, and everything checks well. So in order from least to greatest, I believe it said we had to do. Our 2.88 is going to be the least, and that was going to be this number right here, 2 and 22 over 56. Next we had negative 2 and 4600ths, and then negative 2 and 1/10. Check your answer. Wow, let me wiggle that one and try it again. And one more try. That's what it said. Yep, I'm right. It's wrong. It just has issues. So once again, how does a number line help you to visualize the order of rational numbers? Well, it puts them right there. All you have to do is follow left to right or right to left, and everything's a piece of cake from there on out. Now it's going to be your turn. Order this set of rational numbers, and it says be careful, it says to do that from greatest to least, not from least to greatest. Be a good idea to use a number line to do that, and check your answers. Go. Did you get it done? Let's take a look at how I would do it. First thing I'm going to do is recognize I've got different types of values. I got mixed numbers, I got fractions, and only one of them is going to be even a little bit challenging to work on, and that's going to be the negative 7 and 13/20. I'm going to come over to the side here, and I'm going to say 13 over 20 times what over what is equal to what over 100. Of course, that's going to be 5. If I do it on the bottom, I have to do it on the top, which means I'm going to have 50. 65 over 100. So that one's going to be negative 7 and 6500ths. The next one, that's already done for us, negative 7 and 7800ths. We do not have to change that one to a decimal at all. It's already done. And the next one is dang near close to being done. It's negative 7 and 1700ths. So we can just write that as a decimal of negative 7 and 1700ths. From there, it's just a matter of ordering them from least to greatest. Whoops, I did not finish that one. That one would be negative 7 and 6500ths written as a decimal right there. So from going from greatest to least, it's going to be the 7 and 7/8. I'm sorry, nope, because we got the negative signs, I'm wrong. The farthest to the right on the number line will be this one, then that one, then this one. So we'll go back to our problem. Going from greatest to least, the farthest to the right is going to be that one, followed by the 6500ths, which is that one, and then that one. Check our answer, and the answer checks. Easy math. And now it is time for us to have an apply problem, where we're going to look at some real-world problems involving comparing and ordering rational numbers. Let's watch the video.
Mr. Plum's agriculture class is growing pumpkins under different conditions. The table shows the difference between the weights of some students' pumpkins and the weight of the pumpkin with the current class record. The weight of which student's pumpkin is closest to the weight of the record pumpkin?
Well, all right, that looks easy enough. We move on to our next slide. It's going to give us the same thing it just read to us there. It is also going to give us a table of pumpkin weights. So what do we need to do? We need to take and change each of these to a decimal value in order to see which one is going to be closest to the weight of the pumpkin. Now we are looking for what? We're not looking for the biggest or the smallest. We're comparing each of these to the record pumpkin. So you've got positive values and negative values. What do we need to find? We need to find the absolute value. So how are we going to approach this problem? We're going to convert each one of these fractions into decimals so that they're more easily to compare, and then we're going to find which one has the smallest absolute value, because the smallest absolute value is going to answer that question of which one's going to be closest. Let's change that to blue. And also we want to know which pumpkins broke the record right here. That's the other question they have. So we've got two different questions we're looking at. Which one broke the record? Well, first off, Ricky and Suni, they're both positive, so they both broke the record. So we can take right now, put in that solution, and you can see right there I've gone ahead and pick Ricky and Suni because they're both positive numbers, meaning they're larger than the record. Now I'm going to pause the video and go ahead and make these conversions here. Alright, I saved you all watching me do the grunt work here, but I've converted each one of these values to their decimal counterpart, and now that they're in their decimal counterpart, I'm going to take and find the absolute value of each one. So the absolute value, of 0.20 is going to be 0.20. The absolute value of a negative 0.18 is going to be a positive, come on pen, right, 0.18. Let's see if I can make that look a little better. There we go. The absolute value of 3.25 is going to be 3.25, and the absolute value of negative 3.00, well, that's going to be a positive 3.00. Now the question was, which one is closest to the record? Well, I circled it right here. The 0.18, that's the one that's going to end up being closest to the original one. So we're going to come back over to our chart, and of course that one belonged to Debbie. Debbie had the closest. Go back to our question screen and scroll down and say which one broke the record. It is going to be Debbie's pumpkin. It's going to be closest to the original weight. Both of them check. That's it for today's lesson. Be sure you give me good quality supporting work on your homework. I know you can do a lot of these in your head, but your head is a dark, lonely, and scary place, and I don't want to have to try and figure out what's going on in there. You must give me your homework with supporting work on paper so I know what you're thinking. See you tomorrow.